Chapter 9, Higher Course, page 100. 9.1, the rules of indices. I've done a few videos for foundation tier. You've got to look at those first, build up those foundations, be strong. Don't jump into grade B all of a sudden. You've got to go back and find out how to do the basic stuff. Here's some general rules from the previous video. Any number x to the power of 0 is 1. Now let me teach something else. I can get you to believe me, or I can prove it, I don't mind. Did you know that any number to the power of minus 1 means 1 over x? Did you know that any number to the power of minus 2 is 1 over x squared? Did you know that any number to the power of minus 3 means 1 over x cubed? I'm sure you know that x to the power of minus 5 means 1 over x to the power of 5. Essentially, this is a symbol for reciprocal. I better write the word again. From a previous unit, you should know the word reciprocal. And that is that, and that, not that one. So I'm asking you to believe that and go and investigate it yourself. So if I'm asked to do, for example, something like work out each of these following. I've got this one, I've got 4 to the power of minus 6. Straight away you say that means 1 divided by 4 to the power of 6. And then your job is to work out what 4 to the power of 6 is. Well, that's really, really unkind, but we've got to do it anyway. So 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5, 6. Well, I know 4 times 4 times 4 is 64. And I know 4 times 4 times 4 is 64. My job is to multiply 64 and 64. So here I go. This has got nothing to do with powers, but here we go. If they ask us something dumb like that, we've got to do it. So 64 times 64, good old long multiplication. 4 4s are 16. 4 6s are 24, plus 1 is 25. So 4 64s are 256. Drop an egg, put a 0 down, because now I'm going to play with the 60s. 6 4s, 24. 6 6s, 36, 37, 38. 3 8. Bam. Add the little lot up. 6, 9, 10, 4. Apparently, 4 to the power of 6 is 4096. Therefore, final answer, 4 to the power of minus 6 means 1 divided by 4096. It's a very, very ugly, titchy little fraction. And there it is. Assume I've made no numerical error. That's the method, and that's the final answer. So don't be baffed by that. I also got to work out the value of, well, it's not very hard, is it? Let's do it up here. 2 to the power of 6 plus 6 to the power of 2. Well, I know from experience that 2 times 2 times 2 is 8, and 2 times 2 times 2 is 8. 8 8s are 64. So therefore, 2 to the power of 6 is 64 plus 36. Isn't that lovely? Comes to 100, which is beautiful. Let's turn over the page and do some more of these little customers. What have we got here? Work out. I've had enough of that. I'm not doing any more. Simplify each of these and put them into index form. No, I've done that on the foundation level. I will now do the grade B ones. Did you know that any number to the power of a half means the square root of the number? Did you know that any number to the power of 1/3 means the cube root of that number? Did you know that any number to the power of 1/4 means the 4th root of that number? Did you know that x to the power of 1/5, any number, is going to be the 5th root of that number? And so when you start thinking about grade B powers and we're going into fractions, you're operating at grade B, and then it does become grade A as well a little further on, and I'll teach it when I get to it. Again, there's not too many examples in the book on page 100, 101, but we've got to do what we've got, and if we need to go to the old course manual, the old book, to get some more examples, we'll do that in class. But for now, get that into your face. Think beyond square root. Think beyond cube root. There's such a thing as a 4th root. For example, the 4th root of 16 is 2. Do you know why? I tell you, because 2 times 2 times 2 times 2 is 16. Therefore, the 4th root of 16 is 2. So let me write it for you. I'm not even sure if that's an example, I'm just making it up. So here I go. 2 to the power of 4 is 16. Therefore, the fourth root of 16 is 2. In the same way that the square root of 16 is 4, because 4 squared is 16. And originally we used to write little 2's there, you know, for square root, but you don't have to do that because this sign starts off being a square root, and if you want to make it into a cube root, you put a little 3 there, a fourth root, you put 4 there, etc. Now, real live examples. 49 to the power of a half means the square root of 49, and you all know that's 7. The 64 to the power of a half means the square root of 64, you all know that's 8. Then what do we got here? 1 to the power of 1/3 means the cube root of 1, which is still 1. Now there's an example here which I think is out of order, but I'm going to do it anyway because they've not actually taught that yet in the book. That comes later on in question 9, but I'm going to do it anyway. Look at this one. They've got here, and this is really unkind, 32 to the power of 2/5. Now let me decode that for you. This is so worth a change of flavour. That could mean 32 to the power of a fifth and then square it. Or it can mean 32 squared and then you do the power of a fifth. Either way you get the same answer. Bear in mind you don't have a calculator. Who's going to want to work out 32 times 32 and then try and work out, without a calculator, the fifth root of this big giant number? Not me. But look, working down here. What is the fifth root of 32? Bear in mind it's a non-calculator paper, so it can't be a difficult answer. Well, 1 times 1 times 1 times 1 times 1 is 1. Didn't reach 32 at all. 2 times 2 times 2 times 2 times 2 is 32. So, yeah, it's absolutely right. The fifth root of 32 is in fact 2. And now I'm going to square my 2 and get the answer of 4. So this complicated little animal equals 4. Don't bother to go down this route. No. Oh, it's mathematically correct, so let's give it a tick, but don't go down that route. And therefore, since I've shown that, I'll do another one of these dodgy little things. Here I go, look at this. I've got, and it's a lot easier anyway, 8 to the power of 2/3. What does that mean? It means I take my 8, I cube root it, 'cause it's a third, and then I square it. So, cube root of 8 is 2, then I decide to square it. 2 squared is 4. Question 8 gets in the way. I'm going to do question 9 first because I want to stay with these numerical powers rather than working with algebraic expressions with powers. So I'm going to do question 9. If I could see it, I would. Right, look at this one. I've got minus 8 to the power of 2/3. Remember, that means I'm going to take my minus 8, cube root it, and then square it. Well, look, the cube root of 8 is 2, so is the answer going to be 2 or minus 2? Well, from a previous vid, we should know that the answer is going to be minus 2. Alright? Because minus 2 times minus 2 is plus 4, and 4 times the last minus 2 is going to be minus 8. So I've got minus 2 squared. What does minus 2 squared mean? Minus 2 times minus 2, which becomes positive 4, not negative. Sorted. And what's this one now? I can't even read it. Andrew, what does that say? 32 to the power of what? 2/5. 2/5. Great, I've just done this in the previous example on question 6. I'm not doing that one. I will do this one though. Minus 125 to the power of 2/5. Please note, being non-calculator, the powers are going to be easy. This means I take my minus 125, I fifth root it. But it's a third. And is that a third? Yeah, 3? 3.
2/3.
Yeah. These are so small I can barely see them. So that's going to be to the power of 2/3. So I cube root my 125 and then I square it. Well, the cube root of 125 is 5, so it's minus 5 actually. and then I'm going to square that. Well, minus 5 times minus 5 is positive 25. So that is 25. Now, back to question 8. Claims to be grade A, it's so not grade A. It really isn't, it's too easy for grade A. Look at this. I've got 2x squared times 3x to the power of 5. Really easy, look at this. Well, numbers are numbers. 2 times 3 is 6. And I'm going to write down my x. And I've got x to the power of 2 times x to the power of 5. Remember, you add the powers. 5 plus 2, 7. Answer, 6x to the power of 7. Boringly easy. I'm not going to do any more colours, you just got to follow me now. Miss a couple out. 5c squared times 2c to the power of 7. Well, 5 times 2, 10. C's now. 2 plus 7, 9. 10c to the power of 9. And I think I fancy D, looks really good. 4b squared, it's a different one. And then to the power of 3. Everybody inside the bracket gets the power of 3. Let me decode it for you. That means 4 times b squared. Everybody gets cubed. That means 4 cubed, and it means b squared. That's being cubed. Well, 4 cubed is 64, because 4 times 4 times 4 is 64. And the b squared cubed, remember, you multiply the 2 and the 3, b to the power of 6. All together now, 64b power of 6. That's how you write it, don't put a times. This is algebra. That is that. You don't have to show all this, just do it. 4 to the power of 3, 64, b to the power of 2, cubed up, b to the power of 6. Finished. Easy peasy. I'll do the last one, because I suppose it's the hardest one, but I can't see where. 5c squared times 2c to the power of 7. I think I've done this one before, haven't I? Divided by c to the power of 6. I'm going to nick this from over here. Upstairs I've got 10c to the power of 9 divided by c to the power of 6. Well, 10 divided by 1c to the power of 6 is 10. Now take away the powers. 9 take away 6, 3. Answer, 10c cubed. 10 is one of these horrible ones that say, you know, simplify. It's really easy. I'm going to make it fit here, then I'm going to stop. It says here, simplify. 15, a to the power of 7, b to the power of 6, c to the power of 3. Right? There's lots of timeses between there, but you don't show it in algebra, do you? So 15a7, b6, c3. And I should say to the power of, but I can't be bothered, honestly. Underneath, I'm dividing by 3a to the power of 4. That's a good repentant attitude. B to the power of 9, and you multiply by c to the power of minus 2. Do not be baffed. It's got a big star by it, an asterisk, and yellow, danger, blah de blah. It's easy. Let's just put a divide line there. Right, 15 divided by 3, that's 5 on top. A to the power of 7 divided by a to the power of 4, a to the power of 3 on top. B to the power of 6 divided by b to the power of 9 is going to be b to the power of minus 3. And c to the power of 3 divided by c to the power of minus 2 is 3 minus 2, which means 3 plus 2, which is going to be c to the power of 5. Now that's okay as it is. That's correct. But if you want to write it in positive powers only, the b to the power of minus 3 goes underneath the divide line. So that becomes 5a cubed, c to the power of 5, and take this underneath the divide line. Why is that? And it becomes a positive power, because b to the power of minus 3 equals 1 over, remember, reciprocal, b to the power of 3. So that's the bit of knowledge I've used there. And that simplifies down to that ever so nicely. And I will stop there. I think I've got that right. Yeah, I'm happy with that. And that's it. And I'll do standard form in a mo.